So acyl chlorides are another carboxylic acid derivative, and here you can see I've replaced the OH with a chlorine atom here. The way you name these is you change ethanoic acid to ethanoyl chloride, like so. So if you started with propanoic acid and change the OH to a Cl, it become propanoyl chloride, and so on. So why are these useful? Well, they are extremely reactive. They are a really good way of putting in an acyl group into a molecule. Now an acyl group is this part here. Acyl is RC double bond O, like so. So a really good way of inserting that type of group into an organic molecule. And we're going to look at some of those reactions now. So the reactions of acyl chlorides involve the reaction of a nucleophile with these organic molecules. And a nucleophile is obviously going to be attracted to the delta plus carbon. So the nucleophile is generally going to come in and attack that carbon there, and the double bond on the between the carbon and oxygen will go onto the oxygen, and you will end up with the nucleophile there plus Cl minus, which has left eventually. So let's look at these mechanisms now. So the first reaction we'll look at is the reaction of an acyl chloride with water. Very little point in doing this, but this just shows why you need to keep these guys well away from water. So I basically make the carboxylic acid back and HCl. Here's the mechanism. So here's my water molecule here with the lone pair on the oxygen. He is going to be attracted to the carbon atom, and that lone pair will go like so. So I'll end up with this intermediate with O minus like so, Cl like so, and then water added like so. There's going to be a plus charge on the oxygen there because he has donated his lone pair to the carbon atom. Okay, so next step is this lone pair is going to come down and the Cl is going to leave. You can also do the next step as well at the same time. One of these hydrogen atom, well, the hydrogen ion is going to leave as H+, and that bond's going to go to the oxygen. So what will that leave you with? Well, it will leave you with RC double bond O, OH plus H plus Cl minus, like so. Now what will this reaction be called? Well, it's actually called an addition-elimination reaction. The reason why is because in this step here you are adding, and in this step here you are eliminating. So addition, elimination reaction, and it's a nucleophile that does the job. So nucleophilic addition, elimination. Okay, so let's do the reaction now of an acyl chloride with ammonia, and this time I'm going to form an amide. This may be the first time you've seen an amide before. An amide consists of the C double bond O, but you've now got an NH2 group coming off that carbon atom. So how will it work? Well, exactly the same way as with H2O. The lone pair on the nitrogen now attacks the carbon. The double bond goes to the oxygen to give me this intermediate with the O minus lone pair on the oxygen, Cl, but now I've got the NH3 added like so, the plus charge on the nitrogen. So now a nitrogen needs to go, that double bond comes down, the lone pair comes down from the double bond, and the chloride leaves to give you your product, which is going to be your amide, like so, plus H plus Cl minus. Now with this one you have to be a little bit careful because the HCl actually react with NH3, which is one of my reactants, to give me NH4Cl. So the way you actually write this equation is you put 2 there, and rather than forming HCl, you form NH4Cl instead. Okay, this is another way of forming an ester. If I react an acyl chloride with an alcohol, I'll get an ester plus HCl. Exactly the same mechanism as before. So here we go, the lone pair on the oxygen attacks that carbon there. The double bond goes to the oxygen to give me RCO minus with your lone pair on the oxygen, Cl here, but now you've got an O, H, and then a CH3 here. You're going to have a plus charge on the oxygen, so the H goes, the lone pair comes down, the Cl leaves to give you your product. Okay, and the final one is an acyl chloride with a primary amine. So this is methylamine that I've got here. And you make an N-substituted amide. Now what do I mean by an N-substituted amide? It means that the nitrogen atom has got an R group attached, in this case methyl group. So very similar to how I've reacted it with ammonia previously. Because ammonia and is a base, and also methylamine is a base, it will react with the HCl that would have been produced by this reaction. So you need 2 of those, and you will make the salt at the end as well. So just remember that. Okay, so let's look at the mechanism. So the mechanism is very similar to all the rest. The lone pair attacks the carbon with the delta plus, and I'll end up with this intermediate here with O minus with a lone pair on the oxygen, Cl, and then N with a positive charge on him because he has got 4 bonds. And then the lone pair can come down to form the double bond. The chlorine leaves and the H leaves as well to give you R, C double bond O, and then this N substituted amide like so. And you'd also make HCl, which would react with another methylamine to give you CH3 NH3 plus Cl minus, like so. Finally, for this section, how do you actually make acyl chlorides? Well, you start with the carboxylic acid and you react it with SOCl2, which is sulfur dichloride oxide. That's a liquid at room temperature, and it will react with carboxylic acids to produce the acyl chloride and also sulfur dioxide gas and HCl gas. So this is a relatively nice reaction in that the 2 gases will just leave the reaction to leave you with your acyl chloride. Obviously you will still have to purify your acyl chloride because it's likely you would still have some SOCl2 around and also some carboxylic acid that hasn't quite reacted, so you'll need to fractionally distill the acyl chloride off of that. However, you don't need to worry about the SO2 and HCl because that will just leave the reaction as a gas.